Good morning. I am Shobhik Mondal from Electrical Department PCIT. I am going to teach today Junction Field Effect Transistor. Okay, so before going to Junction Field Effect Transistor, let us start from FET. FET stands for Field Effect Transistor that we can see from here, and it is used generally as switches, amplifier, and logic switches. And type of FET, different type of FETs or field effect transistors are there. One is MOSFET, another is depletion type MOSFET, another is JFET. JFET stands for Junction Field Effect Transistor, whereas MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. Okay, so this is the total classification of FET, where we can see this FET block can be divided in two parts, JFET and MOSFET. The MOSFET is also called IGFET, which denotes insulated gate field effect transistor, also this one. And now JFET is also two types, N channel JFET and P channel JFET. And under MOSFET, we can see two type of MOSFET depending upon the construction. One is enhancement type MOSFET and another is depletion type MOSFET. And in each case, we can make, or according to the construction, we can make N type or say P type, like N type enhancement type MOSFET and P type enhancement type MOSFET. Similarly, in depletion case, it can be divided in two parts: N type depletion MOSFET and P type depletion MOSFET. Now, FET is same as BJT, whereas BJT is a current control device which controlled by IP current, means base current, whereas gate is controlled. This FET is controlled by VGS or gate to source voltage. So from that we can say that BJT is a current control device and FET or FET is a voltage control device. Junction field effect transistors consist of piece of high resistivity semiconductor material, which is generally taken as Si or silicon, which constitutes the channel for the majority carrier flow. So this is a majority carrier device. So the one of the majority carrier, maybe it can be electrons or it can be positive charges depending upon which type of device it is. If it is a N type device, then it should, the majority carriers will be electrons, whereas if it is P type, then the majority carriers will be positive charges or holes. Now from the diagram we can see a JFET has three terminals. One is gate, another is drain, another is source. So three terminal device: gate, drain and source. From the internal constructional diagram we can see that it has two layers of P plus region is induced inside N region. So two P plus region is induced inside N region to make the layer, and from one side of the N channel layer we got a D, means drain. From the other side of the N channel layer or N channel semiconductor layer we got S, and in the both side of the P plus region we get G, means gate terminal, and generally from here also gate terminal is taken, and afterwards these two lines are short circuited to get one single gate terminal. Okay, so this is a complete structural diagram of JFET, where we can see clearly. So this blue layer is the main semiconductor layer, which is taken as N-type semiconductor, where on this N-type semiconductor two P layers has been diffused. These two P layers or P plus layer we can say, and and from these two P layers gate terminals has been taken. So this one and this one. So after that, these two P layers or these two terminals is short circuited to get the gate terminal, and from for drain and source terminal we take two ohmic contacts here, or metallic contacts like this, and from the upper one it is drain, and from the lower one we get the source. So this is the symbol of circuit symbol, or only symbol of JFET, where this defines D means drain, G means gate, and S means source. So the VDS, or the drain to source voltage, is totally dependent upon the supply given between drain and source, and VGS is dependent upon the supply or the gate to source voltage given in between gate terminal and source terminal. So how it works? So at first we have to take that there is no VGS, means VGS is equal to 0. We are taking, or we are not giving any gate voltage in the gate to source junction. We are only providing the main power supply in between, or main voltage in between drain and source, which is written as VDD. So the main working principle of a JFET, it generally stays in turn on condition whenever you are we are connecting the device across this drain and source, or we are connecting a voltage source across drain and source. So as per that, when drain and source is supplied by a VDD, a voltage drop we get across this drain and source terminal. So we get a voltage drop across drain and source terminal. So as a result, electrons are injected through source terminal. As we can see here, the plus terminal of the supply is connected to the drain, and minus terminal is connected to the source. So through the minus terminal, electrons are injected inside the JFET N layer, so creating, and the electrons flows through this N channel. So this area is called N channel. So electrons flow from source to drain, whereas as per the normal rule, the current flows from drain to source. Current flows from drain to source. Now this is the condition where we have not applied the VGS. Now in this condition, if we increase the VDD supply slowly, so at a point when the VDS, or the drain to source voltage, becomes equal to pinch off voltage, then what happens? The depletion layer on between P and N type semiconductor gradually increases and touches each other, resulting the blockage of path of electron. So when the two depletion layer created in between two P layers touches each other, and it blocks the path of electron, so it also blocks the path of current flow from drain to source, and that condition is called pinch off. So this voltage at which, the VDS voltage at which the current conduction stops through JFET, is called pinch off voltage. Now let us talk about the VGS. So now what we have done, we have given some voltage what that is greater than 0 across drain and source, but here we are using the gate terminal also, means we are giving, or we are supplying a gate to source voltage to control the depletion layer created inside the N channel here. So this is the N channel. So when here the connection of gate to source voltage is to the gate terminal, minus terminal of the battery or DC voltage source will be connected, and in the source terminal, positive side of the battery or the DC supply has to be connected, so that when we increase the gate to source voltage gradually, at some point this depletion layer again this depletion layer again will touches each other, creating pinch off where but in this case this VDS is not varying. We are keeping the VDS same. We are varying the VGS or gate to source voltage. So in this condition, by varying the VGS value, we can control the current flowing through this JFET from drain to source, and also we can get to cutoff region of the JFET by increasing a higher value of gate to source voltage, where VDS or we should say the VDD is has the same value without any change. Okay. Now this diagram shows, see, this is a single DC voltage source. So at first, when this green DC voltage source or this one DC voltage source has been applied, this amount of depletion layer is created like this. Now after that, we again increase the VGS across the gate and source, negative VGS across the gate and source terminal or gate and source voltage. So this blue one, when we add some more voltage, again the width of the depletion layer increases, which is shown here as or in blue color. So the width of the depletion layer changes from this green to blue in both sides. And when we again increase the negative VGS or minus VGS, the last depletion layer is created, which is drawn in orange color over here. And when it reaches, it touches each other, creating the V pinch off. So here the first case, these things we have already discussed. So the first case is bias is 0 and depletion layer is thin, low resistance channel exists between drain and source. So there is no biasing voltage. So depletion layer is very thin. This is the depletion layer, this hashed portion, and N channel is created. Whenever we supply, it will start to conduct. In this condition, has been applied, negative VGS has been applied, and we can see with increasing 0 to some higher voltage, if VGS is increasing, gradually the depletion layer width is increasing, narrowing the N channel. Lastly, when VGS value is larger, this depletion layer and this depletion has touches each other and creating this pinch off condition. Now, water analogy for the JFET control mechanism. Not only JFET, all the semiconductor devices can be can be viewed as a from a water tap, where the tap valve control is taken as gate, the tank is taken as source. So let us say here one tank is there taken as source, and the the water outlet is taken as drain. So as per we rotate the gate or the knob of the tap, whatever source may be, the flow of the water will be controlled. Tank has several amount of water, but as per the rotation or of knob, if it is fully open, then high amount of water will flow to the drain. If it is it is kept at half position, then less amount of water will come out from the nozzle, irrespective of how much water is kept in the tank. Okay, so this is the symbol in case of N channel and P channel. So in case of N channel, we can see, so in three cases or all the cases, these pin names are same: drain, gate, and source. But we have to see the direction of the or arrow direction of the gate. So in N channel JFET, we can see the arrow is inward direction, whereas in case of P channel, the arrow is outward. So we have to remember this from where we have to draw the symbol. If we are using N channel, the arrow should be inward, and if it is a P channel, the arrow should be outward. It shows the conduction of current or electron. So JFET is a high input resistance device that we have already said, and if the channel is doped with a donor impurity, N-type material is formed and the channel current will consist of electrons. If the channel is doped with an acceptor impurity, it will make a P-type material. So depending upon the impurity material or impurity type material, it can be made N-type JFET or it can be made P-type JFET. So these things we have already discussed. Okay. Advantages of FET: high input impedance. So good use of these devices in different amplifiers, that can be audio amplifier or signal amplifiers. Then stable temperature than BJT, so it has a stable temperature coefficient than BJT. Size is also low than BJT. Can be fabricated with fewer processing, so the processing system or processing system is also small. BJT is bipolar conduction, both hole and electrons, whereas FET is unipolar, means only one type of conductor is responsible for the current conduction. That means it is a unidirectional device. Less noise compared to BJT and usually use a logic switch. Okay, so different applications are there in of BJT over of FET over BJT. So okay. Now let us say in case of P channel, what we have to do? We have discussed about N channel, but in case of P channel, what we have to do? In case of P channel, if we want to achieve the same process of operation in between drain and source, we have to connect the voltage source. Plus will be again connected to drain and minus will be again connected to source. Whereas this gate to supply or gate to source voltage VGG, gate to source voltage is connected here in a opposite way or reverse way. Plus terminal of the DC supply is connected to gate and minus terminal of the DC supply is connected to source to achieve the same operation in case of P channel JFET. So thank you for today. We will continue on the next video.